friends, welcome to BS Studies. I am Bala. Yesterday we have completed velocity and acceleration. I will explain again what is about acceleration. Acceleration means change in velocity by time. Change in velocity per time. For example, if car is at rest, here u bar means initial velocity. U bar means initial velocity. Okay. Here v bar means final velocity. T means time. These are the terms used in acceleration. So, for example, if a car at rest and within 1 hour it moves at a 180 km per hour. A car at rest. A car at rest means u bar is equals to 0 because initial velocity is 0. It is at rest. So, and travels with 80 km per hour within 2 hours. Within 1 hour. A car at rest and travels with 80 km per hour within 1 hour. Here the question says that a car at rest means u is equals to 0, initial velocity is equals to 0 and travels with 80 kmph, final velocity is equals to 80 km per hour and within the 1 hour. So time is 1 hour. So here how we will calculate acceleration? Acceleration formula is change in velocity, which means v bar minus u bar, v bar minus u bar by time. Okay. So here 80 km per hour minus 0 by 1 hour. Okay. So here 80 km per hour square. Here u bar is equals to 0, v bar is equals to 80 kmph, t time is equals to 1 hour. Here we already know acceleration formula v bar minus u bar by t, which means change in velocity per time. Change in velocity per time is equals to 80 minus 0 by 1 hour. Here in numerator kilometer per hour is there and denominator hour is there. So here 80 km per hour square will be found because it reciprocals to denominator. Okay. And types of acceleration. Types of acceleration. Types of acceleration. In this first one, uniform acceleration. In this uniform acceleration, which means particular change in velocity per time is equal in all cases. For example, I am taking freely falling body, which means this is ground and this is ball. The distance between ground and the ball is h, height. It is at a height. I am holding this ball and if I throw this ball to ground, it will fall like this. Some intervals. So here initially the velocity is equals to 0. So here for this ball final velocity is equals to 1 meter square, 1 meter square, 1 meter per second. Sorry. In this case, velocity is equals to 1 meter per second, and in this case velocity is equals to 1 meter per second. Okay, so here time is equals to 1 second, time is equals to 1 second, time is equals to 1 second they give. In this, initial velocity is 0. In this case, velocity is 1 meter per second in 1 second, and velocity in this case velocity is 1 meter per second in 1 second, and in this velocity is 1 meter per second in 1 second. So the acceleration is, in this case, in these two balls, the case is a bar is equals to v bar minus u bar by t. So here final velocity is 1 meter per second minus initial velocity 0 by time 1. So here 1 meter per second square is the answer, because 1 minus 0 1, 1 by 1 1. Okay. For these two balls, we have to use u is equals to 0, because in these two cases where initial velocity is not there, so we have to take initial velocity 0, and in this case acceleration is final velocity 1 minus 0 by time 1. Here also 1 meter per second square. Okay. For these two cases, we are initial velocity we have to take 0 and final velocity 1. Then acceleration is equals to 1 minus 0 by 1. 1 by 1 is equals to 1 meter per second square. Okay. We have to use initial velocity as 0 in these two cases and this case. Okay. This is the uniform acceleration, because in first case 1 meter per second square, and in second case 1 meter per second square, and in third case 1 meter per second square. The acceleration is equal in all cases. So this is uniform acceleration. Here example is freely falling body. This is an example of freely falling body. Okay. Non-uniform. Non-uniform. Non-uniform acceleration. Here non-uniform acceleration means in all cases there is no equal acceleration. If we take 3 cases, in those 3 cases there are different accelerations, which means non-uniform acceleration. For example, car is moving in a crowded road, because in crowded road we can drive in 10 meter per second, 20 meter per second, 30 meter per second, in 50 also. So there is a change in acceleration in all cases. Okay. And the third type, negative acceleration. Negative acceleration. If I take initial velocity, final velocity, here initial velocity is greater than final velocity. Initial velocity final velocity can initial velocity పెద్దదైతే ఇది నెగటివ్ యాక్సిలరేషన్ అవుతుంది. ఫర్ ఎగ్జాంపుల్, a car is initially moving at 40 km/h. So in that initial velocity is 40 km/h, and it comes to rest, which means final velocity is 0. A car is coming to rest 1 hour. So here acceleration is v bar minus u bar. So here 0 minus 40 minus 40 minus 40 by 1, which means minus 40 km per square hour square. Okay. In this, initial velocity is bigger than final velocity. Okay. This negative acceleration is also called as deceleration. Deceleration. In this deceleration, if acceleration is negative, deceleration is positive. Okay. In this, acceleration is positive, deceleration will be negative. If acceleration is negative, here deceleration is positive. Here acceleration is positive, deceleration is negative. Okay. Fourth one, positive acceleration. Here positive acceleration means I am taking initial velocity u bar and final velocity v bar. Here final velocity is greater than initial velocity. Initial velocity చిన్నది final velocity పెద్దదైతే ఇది positive acceleration. For example, a car is moving at a 40 km/h. For example, if a car at rest and moving with 40 km/h in 1 hour, so in that initial velocity is 0, final velocity is 40. So 40 minus 0, 40, and time is 40 by 1. 40 kilometer per hour square. So here acceleration is positive. So this is a positive acceleration. The conditions for positive acceleration is u is equals to 0, v bar is some k constant and t is some k constant. So here acceleration will be positive. Okay. When final velocity is 0, initial velocity is some k constant and time is some k constant. Here acceleration will be negative because final velocity is 0. Here final velocity is some k. Okay. This is the fourth type and fifth type. Zero acceleration. Here initial velocity is equals to final velocity. Here initial velocity is equals to final velocity. For example, if a car is moving with a 40 km/h initially and finally 80 km/h. Sorry, 40 km/h. So in that time any can be for 4 hours, 10 hours, any how much any time. But the case is initial velocity is equals to final velocity. Here velocities are same because velocities will be same. Acceleration will be 0. Okay. This is the fifth type. So types of acceleration is completed. In types of acceleration there are 5 types. What is 5 types? Uniform acceleration, non-uniform acceleration, negative acceleration, positive acceleration, zero acceleration. Okay. So problems. In this first one is car is at rest and moving with the velocity of 40 km/h and with time 5 seconds. Then acceleration will be here car is at rest. Rest means initial velocity is equals to 0 and moving with the velocity 40 km/h. So here final velocity is 40 km/h and time 5 seconds. So here final velocity is in km/h, bigger units, and time is in seconds, smaller units. So we have to change this as smaller units. So V bar is equals to 40 into 5 by 18 because the relation between kmh and meter per second is 1 km/h is equals to 5 by 18 meter per second. So 2 table 9 times, 2 table 20 times. So there is no cancellation. So 20 into 5, 100 by 9 meter per second. This is the final velocity and we have to find out acceleration. 100 by 9 minus 0 by 5. Okay? So here 100 by 9 minus 0 means 100 by 9 only. So 100 by 9 into 1 by 5 because it reciprocals to denominator. So 5 ones, 5 20s. Here 20 by 9 meter per second square is the acceleration. Okay? A car is moving with the velocity 40 meter per second initially and finally it moves with the speed of 40 meter per second with time 1 second. So here they are asking acceleration. What is acceleration? So here car is moving with the velocity 40 meter per second initially. Here initial velocity is equals to 40 meter per second and finally it moves speed of 40 meter per second. Here final velocity also 40 meter per second. Here time is 1 second. Okay? Here initial velocity is equals to final velocity. This is the case when the initial velocity and final velocity are equal, then this is zero acceleration. Here initial velocity and final velocity are equal, then it is zero acceleration. Okay? And today's class is completed.